Alright, as we get into chapter 2, it's all about triangles. So, you know what a triangle looks like. It's got 3 sides and it's got 3 angles. And there's all different types of triangles. The sides are line segments, and the angles, there's 3 angles. There are the corners, the points at the angles are vertices. One would be a vertex. If you have more than one, the plural is vertices. Okay. So corners are labeled, they're points, so you label them with capital block letters, just like we did before. And so you have 3 line segments that come together to make a triangle. The perimeter of a triangle is just the distance around that triangle. So if you know the lengths of the 3 sides, you just add them all up, and that's your perimeter. So the main part in this section is classifying triangles, and we can classify a triangle based on how big its sides are, or we can classify it by how big its angles are. So there's 2 lists here, and actually every triangle can be classified by a word off of each list. So an equilateral triangle, equilateral means equal sides. Lateral means sides. So an equilateral triangle has all 3 sides congruent. They're all 3 the same length. An isosceles triangle, technically the definition is at least 2 sides congruent. Usually we just differentiate. If 2 sides are congruent, it's isosceles. If 3 sides, we call it equilateral. But technically an equilateral triangle is a special isosceles. And a scalene triangle is when all 3 sides have different lengths. So no 2 sides are the same, and that is scalene. Now we could also talk about triangles based on their angle measures, and we've talked about before where an acute angle is an angle less than 90, an obtuse angle is an angle greater than 90, a right angle is a 90-degree angle. In an acute triangle, all 3 angles are acute. So if all 3 angles are less than 90 degrees, it is an acute triangle. In an obtuse triangle, there's 1 obtuse angle, and there are 2 acute angles. There cannot be more than 1 obtuse angle, because you wouldn't, if we have an obtuse here and we try to put an obtuse over here at this end, we'll never get a triangle out of that. Those 2 sides aren't ever going to meet. And then a right triangle, similarly, there's 1 right angle and 2 acute angles. So a triangle is going to be off of each of one of these things. It can be acute and equilateral. It could be acute and isosceles, etc. So there's a few here that we're going to classify. So we want to do 1 word off of each list. So in this first one here, we notice that all 3 angles are smaller than 90 degrees. So that is an acute triangle. Now, when 2 angles are the same measure, 2 sides will also be the same measure. So this triangle is isosceles. 2 sides are the same, the third one is not. In the second picture here, we notice this little marking in the corner indicates that that's a right angle, which means this is a right triangle. And if we look at the lengths of the sides, they are all 3 different, which means it is scalene. Okay. Sometimes we don't actually know the lengths of the sides, but these markings, when the markings are the same, the sides are the same length. And since all the markings are different, they are all different. So this one is also scalene. And if we look at the lengths of the sides, there's an obtuse angle, so it is an obtuse triangle. Okay, so just remember, just keep the 2 lists separate, and it might make sure you're thinking about which list. If I ask you about angles, acute, obtuse, or right. Okay, now isosceles triangles have some special properties. An isosceles triangle has 2 sides the same length and a third side that is not. So this one is different. Okay, these 2 are called legs, and this one is called the base. So then the two angles at either end of the base are called the base angles. Those are the base angles. Base angles of an isosceles triangle are congruent. Okay, so the two base angles will be the same size. And it doesn't matter where this is situated. I could have another one, you know, a nice, excuse me, an obtuse triangle here that's isosceles. What I do know is this angle and this angle will be the same size. Because in that one, this is the base and these are the legs. The legs are congruent and the base is different. Okay, and then the other angle is referred to as the vertex angle. So just a little vocabulary. You have two base angles and then this is the vertex angle. So the vertex angle is between the two legs. This is the vertex angle in this triangle. So just the parts of an isosceles triangle. So whatever your isosceles triangle is, wherever the two congruent sides are. So if I know that, now that on this looks equilateral, let me make it a little different. If I know that these two are the same length, I can make a conclusion that these two angles are the same size. Sometimes, especially when I'm doing proofs, I'll use a little, if the triangle has two congruent sides, then the angles across from those sides are also congruent. We can write that the other way as well. If we have two angles congruent, then the sides across from those two angles are congruent. So we know that about isosceles triangles. A couple examples here. So, no picture, we got to make our own picture. For triangle PQR, PQ and PR are the same length. So, let's go PQR, where these are the same length. Here's the rest of my triangle. The measure of angle P is 40 degrees. Answer the following questions. Okay, so we've turned this sentence into a picture, and now we've got some things to answer. What are the vertices of the triangle? Well, the vertices are the points at the corners. So with points, all we have to do is list them. P is a vertex, Q is a vertex, R is a vertex. I don't have to say point P. Using that capital P means it's a point. What are the sides? The sides are line segments. So line segment PQ is a side, line segment QR is a side, and line segment PR is a side. Classify it using its angles. Well, I only have one angle measure there, but I do know that triangles have to add up to 180. So I've used up 40. And I also know that these two have to be the same if those two sides are the same. So that means they have to each be 70. Okay, so they are all less than 90, so this is an acute triangle. Classify it, oops, typo, using its sides. I know two are the same, the other one is not. It is isosceles. Now, we use this vocabulary here. What side is included by angle R and angle Q? Well, here's angle R, here's angle Q. What is in between them? Side QR. And it's okay to say RQ or QR, that doesn't matter. It's a segment though, so you should have the segment notation over the top. Which side is opposite of angle Q? Well, angle Q is down here. What's across from that? Opposite of is side PR. So side PR is opposite. Which angle is included by PR and PQ? Here's PR, here's PQ. What's between them? Angle P. Whoops, I wrote it in the wrong spot. Angle P. So included just means in between. Which angle is opposite of PQ? Here's PQ. Across from side PQ is angle R. What is the base of triangle PQR? Well, the two that are the same are the legs. The one that is not the same is the base. So the base is line segment QR. Okay, so first part was just getting that picture drawn properly and then answering those questions. A couple more little pictures or definitions for us. The triangle sum theorem we've actually used a few times. The three angles of a triangle add up to 180. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 will equal 180 degrees. Now we have a thing called an external angle theorem. An external angle, if we have a triangle, an external angle would be created by extending one of the sides. So that we have triangle with three angles here. This fourth angle outside of the triangle that we just created is an external angle. The external angle theorem says that the measure of an external angle, so the measure of angle 4, is equal to the sum of the measures. Let me just write this out. The measure of an external angle, I'm going to abbreviate, external angle is equal to the sum of the measures of the two remote interior angles. Okay, so the measure of an external angle, in this picture, that's angle 4. So the measure of angle 4 is equal to the sum, that means we're going to add, of the measure of the two remote interior. So remote means away from. Your remote control allows you to change the TV channel away from the TV. You don't have to touch the TV. So angle 1 is touching angle 4. That's not remote. If angle 4 is the exterior, we're talking about angle 2 and angle 3 are the remote interiors. Okay. And that should make sense. 1, 2, and 3 add up to 180. 1 and 4 have to add up to 180. They both add up to 180 with it. They have to be the same size. Okay. So an external equals the sum of the two remote internals. So some practice with some of that. So this is an external angle. The 2x minus 11 would have to equal the x plus the 72. I can solve for x, add 11 to both sides, and get 83. And we could, yeah, that one is 83. 2 times 83 is 166, minus 11 is 155 for that other angle. This one is just using the triangle sum theorem. They have to all add up to 180. So 4x plus 1x plus 1x is 6x plus 12 equals 180. When I subtract 12 from both sides, 6x equals 168. Divide by 6, and x equals 28. So this angle is 28 degrees. This one is 28 plus 10, so 38 degrees. 4 times 28 is 480 and 32, so 112 plus 2 is 114. And double check and make sure that all adds up to 180. So an external equals the sum of the two remote internals. Let's skip those for right now. A right triangle has one obtuse. Never. It's one right and two acute. An acute triangle, it could be isosceles. It does not have to be isosceles. So here's a couple where we can just fill in some numbers. So using some of the things we've gotten in both sections here, we know this 40, we know this 20, so on and so forth. And we can find the measure of each angle. I feel like I'm missing a mark there. I think we're missing a right angle mark here. Okay, so if that's a 90, okay, then if this is 90, to get 180, the other two are going to have to add up to 90, and that's 50. So then angle 2 is also 90. Now we have a 90 and a 20 for 110.